Hello. Uh, I'll be planning the universal shift register designing in this video. So for that, let's consider the question where they've given the table, the operation table as they've given S1 S0, that S1 S0 stands for select line values. Since two select lines are given, four options are there, four combinations are there, and for each combination, they're specifying certain operation to be performed. So when it is 0, 0, they want the operation to be hold or no change. For 0, 1 combination, they want the operation to be right shift. And then for 1, 0, left shift. And for 1, 1, they want it to be parallel load. Okay. So question will be like, you have to design a universal shift register which performs this operation based upon the value of select line that you pass. Okay, and in case they have not mentioned how many bit shift register you are supposed to design, default you can take the number of bits as 4. Okay, so if you have 4 bits, you need 4 uh, flip-flops, right? And also, since you have 2 select lines, which means you're supposed to use, if you have 2 select lines, you're supposed to use a 4:1 mux. So you need 4 4:1 mux. So this shift register, universal shift register, will be having two important components. Okay, register will have two components. One will be the flip-flop, the other one will be the multiplexer. Depending upon the number of bits, you'll be having that many flip-flops and multiplexer. And the flip-flop that you will be using here will be D. Okay, data flip-flop. So we'll see how to draw it. So first of all, please draw the multiplexer and the flip-flop component diagram. Connections will show later. So you have 4 multiplexers. Okay. And you need 4 flip-flops. You're using D flip-flop. Okay. So you know that 4:1 mux will be having 4 input, 1 output, and 2 select line. So I'll show the inputs here 0, 1, 2, 3. 4 inputs. Okay. There is one output for each one of them, that is Y, and 2 select lines are there. So what you're supposed to do is short all the select lines. All 4 mux select lines are connected together and they are given as S1, S0. So these are the 4 multiplexers. Now coming to the flip-flop, I told you we are using D flip-flop, and this side is going to be your LSB, and here I'm taking MSB. Okay. So this will be D0, Q0, D1, Q, sorry, Q1, D2, Q2, D3, Q3, right? So this is now ready. One more thing is you should know all the flip-flops will be running on the same clock. So you have to give a common clock to all the flip-flops, okay? Connect a common clock to all of them. It can be positive edge triggered or negative edge triggered, that doesn't matter. But make sure all of them are shorted and connected to common clock signal. So your outer circuit is ready. Now based upon the table that is given, you have to make the connections. Okay. Now to start with, if I take the 0, 0 combination, when the select line is 0, 0, the operation you're supposed to perform is hold. So when the mux select line is 0, 0, out of the 4 inputs, the 0th input I0 will be selected and will be connected to the output. Correct? So you may what you have to do now is connect the output of all the multiplexer to the input of the flip-flop, corresponding flip-flop. Okay. Output of all the multiplexer will be connected to input of the flip-flop, right? Now, when your input is 0, 0, they're saying it is hold. Hold means there should not be any change in the output. Your output should not change, which means what you're supposed to do when the 0 is selected, I am passing some value to this through the Y to D3 connection, but that value should be same as my Q3 previous value. It should not change. So I just have to do this connection here. I have to connect the 0th value to Q3. So now just look, this looks like a loop, right? So when your select line is 0, 0, I naught is selected, and if I naught is selected, it gets connected to Y like this. So, and this forms a feedback loop. Whatever was there in Q3, same thing is fed back to D3, and this keeps on repeating. There is no change in the output. That is what was asked in the question. Whenever the input is 0, 0, I don't want the output to change. It should be holding its previous value. So all you have to do is connect all the 0th pins of the multiplexer to the output, corresponding output. Okay, so this green line does the first operation, hold operation, where 0 and Q3, 0 to Q2, 0 to Q1, 0 to Q0. You're just connecting the output of the flip-flop to the mux 0th pin. Okay, I hope this is clear now. Now we'll move on to the second operation, that is 0, 1. What is the operation is supposed to do when the select line is 0, 1? Right shift. So right shift means your data enters this side and you're shifting it towards the right. Your data is entering the MSB and that data will be shifted towards the right, correct? So now this is your MSB. So you have to enter the data to the first flip-flop and then shift it to the next flip-flop. Okay. Since the select bit is 0, 1, so when it is 0, 1, this one will be selected. So I'll directly give the data. The first data will be given as it is to the MSB. This is the data in or input data for right shift. Okay. Remember that for shifting right, data should be given to MSB. Direct data should be given to MSB. So now when 1 is selected, this data passes to Y. From Y it goes to D3. And for shifting, what you should do? The output Q3 should go as input to the next flip-flop. Okay. Similarly, output Q2 goes as input to the next flip-flop. And last one, Q1 goes as input to the next flip-flop. This is shorted here. Okay. So for right shift, direct data is given to first one and output of the first goes as input to next. Output of this goes as input to next like this. But they are all pin number ones, okay? All pin number one should be connected because you are doing right shift for 0, 1 combination. Okay, I hope this is clear. Now moving on to the third one, 1, 0 combination. So for 1, 0, it is left shift. Left shift means data will be loaded from this side and shifted towards left. Okay, so exact opposite of what you did there. Direct data will be given here, D in for left shift. Since 1, 0 means 2, so this is selected. Direct data is given here to the first flip-flop on the LSB side, okay, for left shift. And for the remaining, output should go as input to the next one. So you have connected Q0 here, right? I'm taking Q0 value and connecting it to second pin of next flip-flop. Similarly, I'll take Q1 value, connect it to second pin of the next flip-flop. And the last Q2 is connected to second pin of next flip-flop. This is for right shift. Sorry, left shift. Okay. The green is hold, blue color was right shift. Now the red color will be left shift. So remember for right shift, data will enter MSB and then gets shifted towards right. For left shift, data enters LSB and you're going to shift it left side. Output to next input, output to next input. Okay, now coming to the last one, that is 1 1. Okay, let's use another color. Mhm. Mhm. So 1 1 means parallel load. For the last input, what you are supposed to do, the operation is parallel load. Parallel means at the same time. Load means you have to load data to all the flip-flops at the same time. Load the direct value to all the flip-flops at the same time. So all I have to do is connect direct information to all the four flip-flops. Whatever value I want to store, A, B, C, D, 1, 2, 3, 4, X, Y, Z, all that value will be directly connected to the third pin of all the mux. And from the third pin, it goes to D3, and from here D2, D1, D0. So parallel load means at the same time you're loading the direct values to all the four flip-flops through the third pins of the multiplexer. Okay, so this is it. This is how you draw the universal shift register based upon the table that is given, operation. Even if I interchange these operations for different values, you should be able to draw it. So please look at the value, look at the operation, and then do the connections. Okay, so I hope this is